So today I'm going to be talking about software engineer in specific, and our main question of the day is why does software needs to be engineered? Now I'll have a quick introduction about software since it's our main topic for the day. So software is basically a collection of information, instructions, or computer programs that are used to run machines. Now, software is really important for running machines, giving access for the user to carry out specific actions or activities on their own device. It is the antithesis of hardware, which refers to a computer's external components. It is also referred to as software in this context, especially as we were talking about. Now, importance of software. So now we reached the point where we are going to be discussing the importance of software. First of all, handling big projects. Now, we obviously know that big businesses and big industries, they need system software. It is very practical for these businesses to have because it's just making it more efficient for them, right? Because like they have large projects and they need something to manage this for them, which leads us to the second point, that is reduces complexity. So not only it helps them to manage everything going on their files, on their applications, but it also is excellent way to make it flexible for them to make things less complicated. In other words, things are less challenging for them to do, and it makes the simpler ones and addresses each one separately, so it's such an easy way. Which leads us to the third point, to decrease time. So it manages their big projects. It makes it less complicated, which we already discussed in the first and the second point. Now, in the third point, to decrease time. It's such a lifesaver and, not time consuming, since these big businesses, they don't have time to waste. And this is exactly what the software is giving to them. So handling big projects, reducing complexity, and decreasing time, that is being so efficient for them. Now, we are going to be talking about system software. Now, we're just going to be talking briefly about it since it's a very important point. The packages in the software are to help set off the computer. Both the software and the hardware features are relying on the system software itself. So this is very important, you guys, when we are talking about this point. So now we reached a point to discuss system software. Now, system software is basically the packages in the software that are to help set off the computer. So it helps the computer to work, to carry out certain activities, and to carry out certain actions. And both the software and the hardware features are totally relying on the system software itself, which is very important. For example, the firmware, computer language, translators, and system utilities are more examples of system software. Moving on. Now we are going to discuss the types of software. First of all, programming software. This is the use of programming language by programmers to fix or create or write or do any sort of activity or programming act and an inputting act in the software. Now, basically, this all can be possible by using the tools required and specifically the programming language. This is very important for programmers as it allows them to, alter any changes or do any type of input which they need to do at that time. Now, moving on, driver software, also known as device driver. It is a type of system software, basically, which manages the collection of devices that are linked to a computer, giving them the access to carry out any sort of action and activities that are unique to them. Now, basically, a device driver is required for the functioning of any connected devices to a computer. Now, for instance, if we are going to take any example, like specialized gaming controllers that comes with software, as well as standard gear such USB, such as USB, storage devices, keyboards, headphones, and printers that is enabled by software. Now, some basics of the principles of software actually. We have number one, the use of a staged life cycle approach to management. Number two, uphold strict product control. Number three, use modern programming practices. Number four, use better and fewer people. And finally, maintain clear accountability for results. These are some of the basics and principles of software engineering. Now let's cover the duties of software. Number one, system design. Now, obviously, it sounds really obvious. It is the designing of any certain thing, like a certain activity that someone needs to design their application by using the programming design tools and all of these. Moving on, troubleshoot and upgrade existing systems. We also spoke about somehow how programmers are able to alter any changes by using the tools required. Moving on, establish new documentation. It is the ability for them to create new documents on their own devices, and this is some of the duties of the software itself. And finally, comply with company and industry standards. Obviously, we spoke about how these big companies and businesses need the software so they need the software to make their life easier and less time consuming and more flexible. Now, how does software work? Now, basically, we are going to talk about how it works, and it's usually the fact that it offers the instructions and the data that computers require to function. And however, application software and system software operate quite differently. Now, here we are introduced to two different types of software. First of all, let's talk about the application software. It's basically a set of applications that can carry out multiple of different tasks. For instance, the creation of reports, being able to access certain websites, and so on. These applications can work with other applications to complete other tasks as well. These apps on computers can't work on their own. They require the operating system and its packages, its essential elements, and their interrelationships. Now, architectural design plays a very major role in software, in engineer in general, and it actually relies on the architectural design tools. Now, next we have the high level design. This is the second design layer. So in this part, which focuses on how the system and each of its parts may be implemented as software stack supported modules. Here the connections are between the information flow and the various system modules and operations are described in a high level design. It's like the second layer that comes after the architectural design, which finally leads us to the detailed design. So this third layer focuses on all the implementation details necessary for the specified architecture.